And welcome everybody to a really great Subnet Saturday. My name is Keith Barker. If you are just joining us, I've got a few words to say, and that is welcome aboard. I have so many thoughts I'd like to share with you. I'm going to hang on to most of those until after we finish the topic at hand, which is reverse engineering for IPv4, including the new CCNA exam, my thoughts on that, the things I've been hearing, the things I've been seeing, and also Cisco Live coming up with the COVID-19 thing going on and some tips for that. So I'll cover all that at the very tail end in the Q&A section. So our focus today, and I'm so tickled pink that you're here, our focus today is IPv4 reverse engineering. Now, for those of you who have the equivalent knowledge or you've been with us through these Subnet Saturday sessions, we've had, I think this is session number 9 now, which is getting up there. I'm hoping that you have the knowledge from the previous 8 sessions that we've had together as we've enjoyed our time together, from the basic foundations of what an IPv4 address is and how the mask works, then custom subnetting and variable length subnetting, binary to decimal, decimal to binary, all those really cool tricks that we can now do, the finger game, the block size. And now what I'd like to do is share with you a really important aspect about IPv4 subnetting, and that is, well, let me tell you about an experience that I had early on in my career. This is when I was first learning subnetting and not really good at it yet. I was on the 41st or 42nd floor of a building in Los Angeles, and I was at one machine, and it was after hours. I was allowed to be there. I wasn't hacking. I was allowed to be there, and as I was configuring the IP address, the DHCP for whatever reason wasn't working well, and they told me that the default gateway was going to be the first IP address on the subnet. And so I looked at that client's IP address, and I thought to myself, oh, the first valid IP address on that host is going to on the network is going to be 1.1. Put it in, didn't work. I thought, uh-oh, I'm in trouble. And I was in trouble for real because I didn't have enough knowledge at the time to reverse engineer it. So what I'd like to do in this video, our objective is to take an IP address that we're given and say, okay, based on that IP address, what subnet is this guy on? What street? Like, you look at the IP address based on the mask and the IP address. Is he on Elm Street or 1st Street or 21st Street? Or we would be using network addresses. Like, is that 10.16.2 or 10.16.4? Or what is that network that customer is connected to? So leveraging everything we've learned up to this point, that's our objective for this video and for this live stream. And I also I'm looking at the queue. I'm so grateful for everybody being here. If you have questions for me directly, there's a lot of people in this room right now who are willing to help, and I'm very grateful. If you have questions for me directly, hold on to those. And at the end, after we finish, I'll do a quick pause. We'll come back for a Q&A, and then you can direct those questions directly at me if you'd like, and I'd be more than happy to take a look at each and every one of them and give them a shot. Our focus, again, is on CCNA and that topic. Oh my gosh. I've got some great new ideas, too. I'll hold that for the end. All right, let's take a look at our topology, and let's play a what-if game. I'm going to move this. This is called EpicPen. A lot of people ask me, hey, Keith, how do you write on top of stuff? I use this. It's EpicPen, and I can change my colors like this. Boom. EpicPen. And there's an eraser. So here's the eraser. Well, what did you learn in the live stream? Well, Keith uses EpicPen to write on top of virtually anything, web pages, whatever you need. So I'm going to go ahead and hide that and scooch it over here, just like that. And I will put on a little camera here. Hello. And let's, instead of this topology, let's bring up a chalkboard and just have some fun from scratch with a brand new chalkboard. That'll work. Let me bring up another layer here. Also behind the scenes, I use a program called Painter, but Painter's just another application. So, all right, let me make sure my chalk is working. Hello. Yeah, seems like it's working. Great. So I'll back that off. Okay, let's do this. I made a few notes here too so I could stay on topic here today. Let's imagine, as I pick up my other pen, and let me go ahead and pick on a color like this for the topic. Oh, by the way, if I haven't mentioned, it's great to have you here. Also, if you don't want to miss any updates when I have a new posting out or a new live stream, I do about 3 a week now, filling up the CCNA library, including subnetting. Click on subscribe. Make sure you're going to get those alerts, and I'd love to have you. If you have a friend you can study with, that's always better. It's better to study with a friend. All right, so let's take a look at a host. Let's imagine we have a network here. Boom, I'm going to draw it old school. There's a network. There's a PC. That PC represents a device with an IP address. And there is a router. And so perhaps that router, maybe it's R1, and it's got connectivity out to the rest of the world, making sure it's not hitting my face. No. Just put an arrow there to remind myself, don't draw on Keith's face or behind Keith's face. So here's our PC, here's the router, and we have a network in common between there. So this may be the, let's see here, let me, it's the 99.0.85 network with a /23. Yeah, let's do that. Let's do that. And let's imagine that this PC right here has been given the IP address of 99.0.85. Oh, I just told you what the network was. Let's pretend that didn't happen, because I want to walk through a process how we can reverse engineer that, and we'll do it together. So I'll leave it up because I already wrote it. So 99.0.85.0. Let me back that off one note. I need one more hand. There we go. 85 dot, and let's use .1 with a /23. So if we went to that PC and we looked at it and did, if it's a Windows computer, it'd be ipconfig. That'll show us the IP address in the mask. If it was Linux, we'd do ifconfig, or a Macintosh at the CLI, it'd be ifconfig, or we could use the respective GUIs on those platforms as well. And that simply means that the first 23 bits of this IP address are the street. Of course, in IPv4, we call that street a network. And it also means that the last 9 bits are the actual host address or house address, which in a computer network we refer to as host ID. So all that we've talked about previously, and now my question is, if we were just given that IP address, how do we verify what network this client's on? Because that happens a lot, especially if you have 2 devices. I did a tweet this morning about, and also put it on LinkedIn and Facebook as well, and it had Bob, the user, who is in VLAN 10, and the printer's in VLAN 10. Now VLANs are a layer 2 construct, and what happened was that Bob couldn't print. Why? Bob's print. I love Sean Powers' response. Something about a dot matrix printer from 1980 or something, with the, or an inkjet printer with the ink all used up. Sean Powers is a great guy. He's on our team at CBT Nuggets. A lot of other good feedback too, but it wasn't because he didn't have the right printer driver. It wasn't because Bob's computer it wasn't powered on. It was because they were in different IP networks. It was like the printer was in network A, an IP subnet A, and Bob was in an IP subnet B, logically, even though they're in the same VLAN. There was a misconfiguration. So if we have this IP address, here's how we can determine that this is the actual network, if it is. And I'm going to check my work, because as we go through this process, you'll be able to do it. Also, in the certification environment, the new exam for CCNA, based on probably 10 hours of me watching people's feedback on it on YouTube, it's a bear. I mean, it's really going to task you to say whether or not you can figure out what the details are based on the data they give you. It's not just a simple walk in the park. And IP subnetting was an absolutely tremendous, bigly, oh my gosh, I can't believe I said that. A tremendously big part of that. All right, so here's what we're going to do. There's just a few steps in calculating what network this PC is connected to. And let me go change my colors here a little bit. Let's go ahead, let's just call this Bob's PC. Oh, hold on a second. I thought I was changing my colors. Give me a moment. Oh yeah, here we go. I like to play with new tools all the time, and sometimes there's a learning curve, like just now. So let's say this is Bob's PC. So we can just refer to that as Bob's computer. And here's what we would do. The first step, if you're going to jot these down or recall them, that's great. The first step is to identify the block size. And the way we're going to identify the block size is the same way we've identified the block size forever. It's the value of the least significant bit. So if you're just joining us, we're so glad you're here in this channel, in this group. If you need to backfill this information, there's a separate playlist just for Subnet Saturday that has all the details that build up to this point. So enjoy it today, backfill it tomorrow, and then join us for the next Subnet Saturday, or catch it in the playlist, whatever's the most convenient for you to catch it in. So we're going to ID the block size. So this is a /23, that's the mask. So we'll put our values here for 1 octet of data. 1, 2, 4, 8, 16, 64. As I missed 32. It was a long night last night. Great night though. Went and saw a play, had a lot of good fun. 1, 2, 4, 8, 16, 32, 64, 128. All right. 1, 2, 3, 4, 5, 6, 7. 1, 2, I gotta slow down. 3, 4, 5, 6, 7, 8. And by the way, if I was taking an exam, I'd be doing literally exactly this, just so I don't make a mistake or guess at it wrong, because sometimes on paper, 2 IP addresses look like, hey, these look like they're right next to each other when they're not in the same subnet. So the first step in identifying the subnet that this computer's on is identifying the block size. So the mask, and I'm going to use white here for a moment. So this is going to represent, so the first 16 bits are all network. So this is going into the 3rd octet, and over here to the left is the 4th octet, just so we're all on the same sheet of music. And if we're going for a 23-bit mask, I'll put the mask right here. The mask up to this point would be 16, so 255, 255, 16. Then going into the 3rd octet, I'm just counting out loud. So it'd be 17, 18, 19, 20, 21, 22, 23. That's what we're going for. I put a big line here. I'll go ahead and use a separate color for that. Let's go ahead and use maybe green. Boom. That's our dividing line. And we'd have a 0 for that bit of we have a 0 for that bit of the mask. So on this side we have network, and over on this side we have host regarding the bits. And that's because the mask is controlling which part of the IP address is the street and which part of the address is the host, and that's how it does it. So the block size, getting back to our point here, our block size is the value of the least significant bit, which is 2. So our block size is 2. That's the first step, block size of 2. Then what we could do in that 3rd octet, and this is a bit painful, so let me hide this layer just for a moment. If we have a block size of 2 in that 3rd octet, this is painful, but I want to show you how painful it is, and then I'll show you a solution for it. And let me bring up another layer. Here we go. So if our block size is 2, and I will change my color here a little bit. There we go. So if our block size is 2, and we're in that 3rd octet, I'm just going to put the 3rd octet here. For that 3rd octet, our subnets are going to be, let's imagine we're starting at 0, 0, and then the block size is 2, we'd add 2. So next subnet would be 2, then 2 more. So the next subnet would be 4, next subnet would be 6, next subnet would be 8, next subnet would be 10. Are you with me? I'm just taking that 3rd octet and we're just adding to the block size to determine the next subnet, the next subnet, the next subnet, the next subnet. So if we were starting with 85, which was in the example, so if we start with, well, that's not the actual network. So we start with that whatever the networks are, and we add the block size. We've covered that previously. Now, if we're trying to get up in the range of the 80s, how many do we have to go here? I mean, we're going to need like 3 sheets of paper just to add 2, add 2, add 2, add 2, add 2 for the block size forever and ever and ever. And that's going to take a long time. So instead of writing all these subnets out, which we have done previously, I just want to show you a shortcut where we can very quickly go to the actual subnet and identify what that subnet is. So let me go ahead and clear that layer, bring back the previous layer, and here's the trick. So the first one is to identify the block size. And then what we're going to do is this 3rd octet, which I will just circle here. Let me get out the right pen for this. How about that color? That'll do. So in that 3rd octet, what we're going to do is this. We're going to simply divide the octet. Now, when I say the octet, this is the octet where the last bit is. So in our mask, the last bit is in this 3rd octet somewhere. It could be the last bit or the first bit, or in this case, the 7th bit over from the far left. You take that octet and you divide it by the block size. I should probably spell size right. It'll look better. Okay, so if you're not like super great at math, you don't have to be here. The concept is, number 2, we want to take that octet where the dividing line is somewhere in this octet. So we'll take it, 85, and we're going to divide it by the block size. And so in this example, with this last 23-bit mask, the block size is 2, so we're going to do 2 into 85. That's it. So 85 divided by 2. So if you want to do this longhand, like many of us learned in school, we would simply say, well, 2 goes into 8 4 times. Great. So 2 times 4 is 8. And then you work on the next number. This way we have 5 there. 2 goes into 5 only 2 times. Then there's a decimal point. Great. and then there's going to be a remainder. Now here's the deal. We don't care about that remainder. All we're after is how many times does the block size go into that specific octet cleanly. And then whatever that fraction is for remainder, you can just round down to that whole number, 42. That's the second step. So, Keith, let me back up here. You're saying that if you have an IP address, which we do, and a mask, the first step into identifying what subnet this customer's IP address is on is identify the block size. Step number one, great. And then take that octet from that customer's IP address, whether it's the second octet or third octet or fourth octet, it depends on where the mask ends. So wherever the mask ends in that same octet, take that octet and divide it by the block size. And then if there's a remainder, forget about that remainder. We don't care. We're just looking for how many times does the block size go into that octet cleanly. So in this example, we have the block size goes in 42 times. So far, so good. The next step is to go ahead and multiply. So we're going to multiply the block size. I'm going to put BS, but I want you to know that that BS stands for block size, the block of addresses, the block size, just for abbreviation here. Nothing else, just block size. We want to take the block size and multiply that by how many times by that result. So basically 42. How many times did the block size go into that number? 42 times. We're going to take the block size times 42, which is 42, which is, the block size is 2, times 42 equals, and let's do the long math on that. I'll do it right here. So 2 times 42, 2 times 2 is 4. And the reason I'm doing it longhand is because in the heat of battle, in the moment of an exam, or just to be sure, we want to get those numbers right. And so you can, we could look at that and say 42 times 2 is 84, but just take a moment to do it the longhand. It won't hurt a bit. So 2 times 2 is 4, 4 times 2 is 8. That's 84 equals 84. And then the last thing we're going to do is we are going to place that octet in that position and then zero out everything to the right of it. So what that means is that this customer with this IP address of 99.0.85.1 with a /23 mask is, and let me get a little bit more room. Let me, I have an eraser tool and I know how to use it. Let me erase some stuff here. I'm going to go ahead and erase some of that and make it bigger. Drawing tools are fun. My daughter Amber and I have a few other kids. They're also very, very artistically gifted, and it's fun. It's a lot of fun. So I'm going to just make some room up here. Also, I'm going to remove my face, give me more real estate, and let's go ahead and continue this discussion then. So if we take this address, the IP address of the customer, and I'll use a different color for this. Let's go for that color. If it's 99.0. And instead of using that octet, we're going to use this octet, which we got by taking the block size, dividing that block size into that number, and then finding out how many times that goes in. This can be 84, and then everything else to the right will be 0/23. So what that means is that is the network that client is sitting on. Where before, I think we go back to my other notes, which I was rushing on. Let's go back and take a look. Oh, what did I do with it? Oh, it's right here. It's right here. This is the network that I guessed originally that computer was on. That's not the right subnet. This is not the right subnet. This is actually the 84 subnet. That's because I just slapped it up there and said, that looks right, a 0 at the end. This is the 99.0.84 subnet that this client's on. Now, the other question, and this can be very helpful, is how do we identify what the range is for this subnet? And this is a trick that you and I have done many times previously in these Subnet Saturdays. And that is we take the block size. So the block size is 2. That hasn't changed. And that's going to be our next subnet in that third octet. So 99.0 our dot plus 2 more, 86.0/23. That's our next subnet. And the next subnet after that would be 2 more. And 2 more, just keep adding the block size, assuming the mask is the same. So our range for this subnet would be hosts 84.1 through, and then we can't go past the next subnet. So the next subnet is 86, so that'd be 85.254 with the 255 address being the broadcast address for the subnet. And then for this next one, the 86 network, the next subnet would be 88.0/23, and so the range for this network would be 86.1 through, the next subnet minus 1, which would be 87.254, with 255 being the broadcast address for subnet B, we'll call it. So that's the process for reverse engineering based on an IP address, reverse engineering what the actual subnet that customer is on without having to guess. Now, the reason I came up with this, and sometimes as a trainer, I've been training for a long time and working in the field for a long time. Sometimes as a trainer, I'll hear ideas or thoughts or ideas, and I think, how can I make that better? Or how can I make that more clear to a learner? And sometimes it's natural, like with a quick analogy, and sometimes it's like, oh, how would an average human do this? And that's why I came up with the finger game like 8 or 9 years ago to calculate how many bits are needed for subnetting or for host addressing, because I thought I need a way without saying the powers of 2. If you notice in this whole Subnet Saturday, I'm not training you to do the powers of 2. We have fingers that we take into an environment with us every time. If it's a certification environment or a production environment, our fingers are there. And we know how to calculate the block size based on the least significant bit. And then we can calculate based on that the new subnets. We also applied that to variable length subnet masking in the previous video. So here's what I'd like to do. Let's clear off the whiteboard. Let's take another. Let me actually add one more piece. The reason the calculation of dividing the block size into that octet is good is because, again, if that third octet is 220 and the block size is 4, you're going to have to write out 4, 8, 12, 16, etc., all the way up. And it just takes too long to figure out the next subnet to get to that point. The dividing the block size into that customer's octet where the mask ends is just a shortcut to get there quicker, so you don't have to have 3 sheets of paper to calculate it. So let's do one more. And one of the things about me is that you might want you already know. I have a little bit of an inferiority complex in general. I'm 55 and I have 2 CCIEs and certifications from many other vendors as well. And I apply myself pretty hard when I do various things, whatever it might be, just like you do. And when I was 16, I was 5 feet tall, and I was bullied a lot as a kid. Not by my family, they're great, but school and other places, I got bullied a lot. So I was 5 feet tall, 82 pounds. That was my first driver's license, so I remember it. It's like on my driver's license, Keith Barker, 82 pounds, 5 feet tall. Hard to get a date. Got pulled over 7 times by police in the city I grew up. Not because I was speeding, and not because the police were being mean, because I just looked like I was 12 or 13, that I just stole my parents' car for a little joyride. So why do I point that out? I usually over prepare almost everything I do. Like at CBT Nuggets, where I spend my full-time job 40 hours a week, I do about 2 to 6 hours, well, probably 6 hours to 7 hours a week streaming. So just for CCNA, Wednesdays at 4 p.m. Pacific, and Saturdays, like today, Subnet Saturday, at 11 a.m. Pacific, and then Sundays, CCNA Sunday, at 11 a.m. Pacific. So I enjoy this. I love it. I love giving back to the community. And normally I do some prep. Like I'll write things out. I'll go through them, whether it's CBT Nuggets content I'm making or whether it's a live stream like this. So I thought what I would do is go ahead and break out of my comfort zone, which has already started right now, and put up an IP address where I don't know the math on it. I haven't done the math on it, and I want to go ahead and calculate based on an IP address with you using the techniques we just talked about, and calculate what subnet that customer's on. And maybe the scenario is like this: you've been given a customer IP address with a mask, and you've been told, yeah, the default gateway, DHCP is not available, but the default gateway is the first valid IP address in the subnet. Go. It's like, how do we do that? Well, we use the same process. I think by doing it from scratch again, without any preconceived, idea of which IP address I'm going to use or how it's going to go, that would be a great chance for us to process it together. As I get out the wrong pen, process it together and then see that process one more time. So let me go ahead and clear my screen right here. I'm just going to remove that layer that I had added. We'll add one more layer, and then I'll bring that over. Plus a little circle cam. Circle cam up in the right-hand corner. There it is. All right. So let's imagine starting from scratch, and I'm just going to pull one right out of the air. Let's use a pen, and let's say that we have a network, and we have a client. And this is not Bob's PC, it's going to be Lois's PC. And the reason you know that that might be funny is if you've seen other sessions with me, you know what Lois and Bob represent to me. So we have Lois here, and she is connected to a switch port. We'll call this switch 1. And let's call this port 1/15. Now, Lois's computer is in a specific VLAN, and the VLAN that's in is based on the assignment of that port. So if the administrator, either directly on that switch, us, or we did it through network automation and we pushed down the commands to it from a controller, if that port 1/15 is assigned as an access port, and VLAN, let's call it 70, boom, that's the layer 2 broadcast domain that Lois's computer belongs to. Now, normally, associated with a layer 2 broadcast domain, a VLAN, we also normally associate a street. Now, the street is the IP network address. So we put an IP network association on Lois's computer and also any other devices like a router that are in that same VLAN, and they have to agree. Or they should agree. If they don't agree on the street name, they're going to have a hard time talking to each other. And so if you have a piece of cable, if you have a brand new switch and a brand new computer and no other devices you plug it in, whatever IP address you put on that computer is the IP address and is the network that that computer is going to believe it's connected to. It's just based on configuration. And then usually in a network design, you'll have the router that's correct with what IP address and what network address it is on that street. So we have some kind of layer 3 IP network address, and let's imagine that Lois's computer is, let me put this in white. I'll just put it over here. 10, so we use the private RFC19 address space. The private address space is the 10 anything, the 172.16 through 31 anything, and the 192.168 anything. So those are considered RFC 1918 private addresses, which means everybody can use them. Just make sure you do NAT before you head out to the internet, because the internet will not route those because they're not publicly routable addresses. All right, we can internally, but just not on the internet. So let's use 10.42.99.204. All right, there we go. And I haven't pre-calculated that math. And for a mask, we're going to use something that's not on a clean boundary, not on an 8-bit boundary. Let's use the /28. Okay? So our task is, now if you're watching this in the replay, you could pause me right here and take a stab at that right now, which wouldn't be a bad exercise. Because sometimes when we think we understand a concept, if we pause and say, okay, let me apply my skills or what I think is true, and we go through it, then we get stuck. We're like, oh, I guess I don't get that part. And then we can really hone in and clarify that piece. That's happened to me dozens of times in my life as I'm learning new things, as I try to express them or write them out or calculate them. I say, I don't know how, I don't know what the next step is, or I don't remember how that works. But through repetition and through going through it a few times, you can gain that knowledge. And then once you have them, they'll be in your memory longer than if you didn't ever learn them. And occasionally refresh and you're good to go. So the first step if we were told, okay, Lois's default gateway, which is right here, we'll call this R1. Lois's default gateway is the first valid IP address on the same network that Lois is on. Now the question is, what the heck network is Lois on? How do we know? And the process is number 1, BS. And that BS is, I'm going to say block size in case you're just joining us. So identify the block size. And so whenever you're stuck or whenever you're starting a problem, there's 2 things that might go through your mind. One is, I'm going to write out the values of the binary of the byte of data, the 1, 2, 4, 8, 16, 32, etc. And the other one is, I'm going to throw up a finger and start counting how many bits do I need using the finger game. One of those 2 things is usually a great starting point when you're trying to solve a problem. We're not asking about quantity here. We're asking about the block size. So let's go ahead and write out our values for a byte of data. 1, 2, 4, 8, 16, 32, 64, 128. Also, for the new CCNA, based on where you test, in the past, we've been given so the testing is done through Vue, and Vue, the company called Vue, VUE. And in the past, they've given us a laminated sheet with a dry erase marker, or maybe 2 of them. and you could write on them, and then when you're done, you could erase them all and then hand them in. I've heard, based on the testing center, and this may vary, that they give you that laminated thing and the dry erase marker, and they say don't erase anything. And then there's a camera watching you also, and they're asking you not to erase anything. So I think they're being more stringent on making sure that people are not cheating in any fashion possible. So here's the thing. If you're going into an exam, if you've been through these Subnet Saturdays and you're going into a CCNA exam or anything that involves subnetting, if you got your fingers with you, check, got them. You've got this table that you can write out on demand, and I've already written out twice in this short video. You write out these values of the 1 byte of data, and that's all you need. And then you can just start calculating. So with the /28, what we're doing is we're looking at this 4th octet. So the 24 bits would be all the way up to here, 8 plus 8 plus 8 in the mask, plus 4 more bits in that 4th octet. So I'm going to go ahead and just make a note that the 3rd octet goes that way, and the 4th octet goes this way, and that we are dealing with the 4th octet. So the mask is in that 4th octet, so we're 24 bits up to this point. This is it, 24. So we're just going to go up to 28, 25, 26, 27, 28, and then that's our dividing line. So everything over this way is the network portion, or the street name in that IP address. Everything on this side is the host portion for host addressing. And so the mask for that portion would be 0, 0, 0, 0, just like that. So what is our block size? That's our first step. Our block size is 16. Fantastic. And then we're going to say, okay, we're dealing with that 4th octet. We could just start off with 10.42.99.204 and just add 16, or we can start off with 10.42.99.0 and start adding 16, adding 16, adding 16, adding 16. You with me? But it would be a long set of all the subnets that we're listing before we ever get to 204. So one solution is, let's take the block size and divide that into that number, which is step number 2. And that is the octet divided by block size. And let's do that together. So this is 204. I would have picked an easier number if I would have picked a smaller block size if I was planning this out ahead of time. But it's a good exercise because any block size could come up. So this is the value from that 4th octet. Our block size is 16, and 16 goes into 20 one time. There's a 4 remainder there. You can borrow the 1 and all that good stuff. And then you bring down the next character, 4. So 16 plus 16 is 32. 16 times 3. I'm just going to do it because I want to verify. So 16 times 3, just to make sure it won't go in. 6 times 3 is 18. 3, 4. Yeah, it's too high. Great. You know, I probably could have done that without having to do that math, but I wanted to verify. And also, I just put that underneath my face. My apologies. There you go. So this 16 only goes into 44 2 times. So we bring that up there. And then there's going to be a remainder. So that's 32. And then we don't actually care about the remainder past the decimal point. So now we have our block size. We have how many times our block size goes into that octet. And then to complete this, we're going to do the block size times how many times it went into the customer's octet. So this is 3. Block size times result. And I will draw an arrow over here. Talking about this result right here. So it'd be 16 times 12. Yeah, shame on me. So there's no calculator on most of these exams, but the math is going to work. So 6 times 2 is 12. 2 times 1 is 2, plus 1 more is 3. Then we're going to put a 0 here and then bring down the 16. Yep. So any way you want to do that math, I just shortcutted it a little teeny bit, but any way you want to do that 16 times 12 is great, as long as you can calculate that. And the total would be 219. So what this, and then the 4th thing is you simply plug that number into that last octet. Plug number, this number in. So this customer, so this IP address for this network would be 10.42.99.192 with a /28. That's the actual network. And if we wanted the first valid IP address on that 192 subnet, it would be .193. And if we are curious of the range for that network, how would we calculate it? Well, Keith, we could probably use that block size trick we've used like 4 or 5 times in these series. You're exactly right. We use the block size. So the next subnet is going to be 16 more. So I'm going to put that here, 192 plus 16. It'd be 80208. So that's our next subnet. So the range, and I'll put this in a different color here. The range for this network would be, oh goodness here, would be 191 or 193, the first valid IP address, through the next subnet, and this is the last octet, so there's no more room to play with on the right-hand side. The next subnet -2, which would be 206, because the 207 is the broadcast, and the next IP address of 208 represents the street name for the next subnet. So that's our range. So this client on 10.42.99.204 is in the network 10.42.99.192 with the /28, and the first valid host address is .193, and if that's our default gateway, that's what we'd plug in. Whew. Yeah, I would have chosen a different example that had less digits in it, but that's how it works. Now, does this technique work with any mask and any IP network, any customer IP address? The answer is yes. If the mask is a /24, the block size is 1. That's actually a pretty easy calculation. If it's a /22, the same process works. Identify the block size, divide that block size into that customer's octet where the mask ends, and then take the result of that times the block size. That's your subnet. And then the next subnet beyond that is the block size again and again and again, and that way you can calculate your ranges very, very easily. So reverse engineering an IPv4 address to determine the actual subnet is a really important skill, because there may be situations in production environments and in certification, both, where you're given an IP address and you're from a host, and you're asked which of these 2 or 3 other IP addresses, if any, are in the same subnet. And you look at the ranges. It's like, okay, what's the block size? What is the subnet? What is the range based on the next subnet and the block size, and adding the block size again and again and again. And then listing out the ranges. Say, oh, easy. And that, although I did it here longhand, I did everything with a few practice runs, you're going to be able to do this consistently and do it accurately. And based on all the feedback that I've gotten regarding the new CCNA, you're going to want the experience and the knowledge of how to understand what IP addressing is, understand masks, and understand subnets, understand VLSM, and be able to reverse engineer as we've done in this video. So that's what I wanted to cover. And we were able to do that in about 39 minutes. Also, I got a question. Let me save the note for that for the Q&A. I just want to make sure this is nice and tight. So here's my goal, is to cover this topic, which we did. Thank you very much for being here. And then go on a short break. And when we go on that short break, what we'll do is I'll get a drink of water, which is always great. And then we'll open it up for like chat, Q&A. If you want to join me, let me give you a link for Discord too. I've got one. And it is right here. And I put this in the chats, so you have something to go to. Hold on one second. Let me make sure it's right. Okay, great. So I just added the Discord link. If you'd like to contact me, if you have questions you'd like to ask me directly, you can join Discord. It is also free, just like YouTube, and you can direct message me there if you want. Also, we've got a lot of great people who are answering questions. If you have a request for a video that's somewhere in the CCNA blueprint, as far as the topic in that blueprint, we've got 6 sections for video requests. Like, I'd love to see a video on this. Many times the video already exists. Another channel member or a moderator will simply say, hey, here's a link for that exact video that Keith did like 8 years ago. Same technology, still works. And sometimes it'll be a new live stream that we recently did. So there's a spot on Discord to request those. There's also a spot for discussions regarding spanning tree and routing and layer 2 switching and trunking and network automation, programmability, all those things. So whether you have a request for a video for CCNA level stuff, or you want to ask a question or a challenge question and get feedback, And if there's ever a spot where there's a discussion going on and you'd like not an arbitrator, but you'd like my 2 cents on it, just throw in the @Keith, I think it's Keith OGIT, in the channel, and one of the moderators as well. And that'll get my attention, and I will jump in and answer it sometimes to the best of my ability. Sometimes I'll just give a clue, or based on what I think would be the best learning experience, provide you additional information. So join our Discord server. It's free. And also I want to share with you a link for subnetting, because I'm looking at the list of people in the room, and there are some new people. So let me give you another link here. Lots of screens. I've got this screen and this screen and this screen. Lots of screens. So that link I just put in is for just a concise playlist regarding Subnet Saturdays. So I think this is our session 8 or 9, maybe 9. So if you want to start from the beginning with Subnet Saturday, like I don't know anything about IPv4 addressing, I realize it's super important to get that knowledge, start there and maybe commit to a few hours a week of just enjoying, watching, learning. And if you have questions, join Discord, ask questions, get answers. It's a great resource. The second thing I'd like to do is, if you are working on your CCNA, I made also a playlist, and this is mostly for people who are new. This is on YouTube also, it's free, of all these live streams and also a few extra videos and tidbits that I've worked in. And I've organized them in mostly a logical fashion that is very similar to the blueprint, where network automation is going to go at the very end. We haven't done those yet, so stay tuned. Those are coming. IP routing is near the middle. Layer 2 switching is near the top. So based on the blueprint, so you can kind of go through them in a logical progression. And then as we do new live streams, which I got some great ideas, by the way, from Discord. So thank you very much for those ideas, including additional IPv6 static routing, which is a big deal for CCNA. I've recently discovered that it's more important than most people are going to expect. So I'll prepare you for that. Anyway, so those will be added as time goes on. And then also just one last piece here before we take a short, like 1 minute break for me to get a drink of water, is many of you know my full-time gig is at CBT Nuggets, where we make, it's a commercial site. It's not free. It's subscription-based. And if you're interested in learning more about that, here's some of my content there. And there's a 7-day free trial. There's no obligation. I think that it's a lot like the story of Goldilocks and the Three Bears. You know, Goldilocks, for those of you who are familiar, you know. For those of you who are new to Goldilocks, I'm glad I can tell it to you for the first time. Goldilocks shows up at the bear's house. This is a fictitious story. She shows up at the bear's house, and there's 3 bowls of porridge, I believe, or some kind of a food substance. And there's Papa Bears, and it was too hot. And there's Mama Bears, and it was too cold. And there's Baby Bears, and it was just right. But you know what? If push comes to shove, Goldilocks could have just gosh darn eaten any one of those and survived. If she needed that food to survive, any one of those would have done. She could take Papa Bears, let it cool off a little bit, take Mama Bears and say it's cold, but it's going to keep me living, and Baby Bears happened to be okay as is. The point of that story for me, as far as learning, is that there is a lot of resources you can use to get CCNA certified. A lot of those are free, and they're here on the internet. That's one thing I love about YouTube, is that there's so many people helping other people learn for free. I don't monetize at this time. I don't monetize any of my YouTube stuff at all, and I'm getting close to 100,000 subscribers, and that's you, by the way. So thank you for enjoying it, participating, all that good stuff. By subscribing, liking it, that lets others know that, hey, this might be something you want to look at in your journey through CCNA. And so there's lots of other great content. There's Udemy. They've got courses. CBT Nuggets, we've got like 52 hours of course material on CCNA plus labs, and they're concise. So we hone in, boom, here's the topic, it's fun, here's a lab, reinforce it, and move on. 52 hours of that with Jeremy Chara, Chuck Keith, and myself, who created that. It's fantastic, but it's not free. Well, my point here is that if you want to get CCNA certified, I would encourage you to learn the content. There's lots of ways of doing it, including mostly free ways, not like a highway, but ways that don't cost money. And whatever works for you, whatever you need to do for your to learn it, I would go for it. So I wanted to make that statement, that there's a lot of great people with a lot of great content free on YouTube, and there's a lot of great paid resources as well, including CBT Nuggets and other companies that can be used. But if you have the desire, that's where I'd start. What do I want to accomplish in 3 to 6 months? And then allocate the time to do it, and then start studying. Packet Tracer, I said this before, but Packet Tracer from Cisco is free, and it'll do everything that you need it to do to help give you hands-on practice for the CCNA level content, including, as I've learned in the last 48 hours, a bunch of details on wireless. So we have wireless in our CCNA content at CBT Nuggets, and it's also important as a CCNA candidate based on the blueprint, and I have not seen the exam yet, so I'm just talking about things that I've observed, is to be able to configure a controller. Or if you're not going to do a simulation, at least know what is on the controller that you can configure, should configure, how a controller works with access points, which, by the way, we're going to include that in our videos here to make sure that you get a nice overview. And one last thing before I take a short break, and then we'll come back for Q&A, is this. If you have a question for me, starting now, if you do an @KeithBarker and then your comment so I can see it, that way I don't have to scroll through the long list that's already there. And oh yeah, one significant difference between these live streams and the content here on YouTube and my full-time gig at CBT Nuggets is that at CBT they're concise. They are like, this topic you're in, here it is, here's why it matters, here's an analogy to help you remember how it works, here's a lab to support it, and then we're out. And this is more like the instructor hours, where I'm a little bit more relaxed. I'm here in my recording studio, and it's a house in Las Vegas that I record out of, and it's a little less structured, sort of like chatting with the instructor, chatting with not the professor, because I don't have a college degree, but chatting with the instructor about the topics, giving you an overview of it, what it is, and then sticking around for a Q&A. So and also we're not, in this channel, there's no way that I can reach the depth and the hands-on practice that we have at CBT Nuggets as well. So that's a significant difference. All right. I'm going to go ahead and give you some music for a few moments and get a drink of water. And when we come back, I'll be happy to take Q&A. My focus would be any questions about our topic today, which is reverse engineering IPv4 would be preferable. My second choice would be anything related to the CCNA 200-301 blueprint. And my third choice, anything that's at the professional level, even though there's some pretty deep topics at CCNA, or anything out of the scope, clearly out of the scope of CCNA, I'd love to take those in Discord, on the Discord server. So save those for me if you have them there, put them in the other category, and that way I can check on them periodically and the other group members can do it as well. All right, and I will go ahead and put on some music. I'll be right back, and we'll do Q&A.
Life is a winding road, no telling where it goes. Driving through days and nights, won't stop for traffic lights. And I really wanna know if I will ever figure out where the road goes. Even if I'm falling down, I will keep on searching for my highs. You can say I lost my mind.
Okay, and I am back to give you a context of where things are in my studio here. I've got the camera there. Hello, it's great chatting with you. I'm so glad you're here. If you haven't subscribed yet, please feel free to do so. If you like the videos or if you got something out of them useful, hit the alert bell as well so you can learn again from the next ones. And my chat screen is right here, so if I'm looking down here, I'm not ignoring you. I'm just going to take a peek at the chats, and I'm just going to focus on the ones that have my name and bright colors so I can actually find them. All right, Anders. Hi, Anders. Welcome. Is asking, have any idea of CCNA 200-301 physical labs should I look for, or maybe buying one at a time? Great question. Let's discuss that with a whiteboard. Well, this is actually a chalkboard, but it'll serve the purpose just as well. And let me grab a pen. So for a lab, I would recommend that you have at least 3 routers and probably at least 2 switches. And if possible, it would be great if these switches could support security features like port security and other security features like dynamic ARP inspection And so when you buy a layer 2 switch, or when you buy a switch, and this could actually be a multi-layer switch, and on that switch, if it's a multi-layer switch, you can just do no IP routing, boom, and it'll act just as a layer 2 switch, no routing capabilities. Or if it's a multi-layer switch, you just simply say IP routing, and it'll enable IP routing. Then it can do layer 2 forwarding, and you can have multiple SVIs, switched virtual interfaces like interface VLAN 10, interface VLAN 20, and configure those with IP addresses and do routing there as well. But from a layer 2 perspective, I support that and that. What else? Port security, dynamic ARP inspection. Oh, and DHCP snooping would be good too, because your dynamic ARP inspection is going to want that information regarding layer 3 to layer 2 mappings that were handed out via IP addresses in DHCP. And I've got videos in the playlist, the master playlist on each one of those. So those would be good ones to look for. As far as other connectivity, I tell you what I wouldn't worry about too much. In the old days, serial. So serial interfaces, I say low speed interfaces like T1 speeds, 1.54 megabits per second. Those used to be critical. Like, oh, you got to have these, especially in the old days, because you had like frame relay and point to multi-point, some other options. But anymore, like routers with T1 interfaces with a back-to-back cable that supports them, one DCE, one DTE side, that's not as critical. And so I wouldn't worry about that too much. But on the routers, they should have, ideally, they'd have 2 to 3 gig interfaces and maybe 1 to 2 fast Ethernet interfaces. My brain cells. Oh, I'm writing over myself. Yeah. Oh, there we go. That works. I'll just put FA. Fast Ethernet interfaces. That way you can carve out what you want to do, and you can have speed comparisons with OSPF versus fast Ethernet interfaces, and you want to do the auto cost reference bandwidth with OSPF so it can tell the difference. By default, routers, they think the fastest bandwidth on the planet is 100 megabits per second in OSPF. And so unless you change that, which we've covered in a previous video on OSPF, you want to change that as well. Another option is this. A person could just get like 4 or 5 multi-layer switches. And then on those, like a 3560 with an enhanced image, they're very inexpensive. And then what you could do is you could do layer 2 trunks on those guys any way you wanted to. And that would give you a chance to practice all your spanning tree. And you could also do inter-VLAN routing with creating multiple VLANs and doing switched virtual interfaces and do your logical routing inside of that topology as well. Or you could also take an interface on a switch, a multi-layer switch, and say no switch port, and that makes it a routed interface. So from a routing perspective, if this is core 1, a multi-layer switch, it would just look like that's a router interface on a router right there. So the interface on a router could be a no switch port on the interface, which is this guy right here, or it could be interface VLAN 10, which would then make that logical layer 3 interface, which doesn't have any physical characteristics. It's just a logical interface inside. So lots of options. Depends on how you want to carve it out and create it. I would suggest before you buy a lot of hardware, although it can be fun, I would suggest Packet Tracer, because boy, it is. Jeremy Chara, who I work with and I appreciate, he's all about having a physical topology that you can plug in and you can see the cables and there is value in, it feels good. It's tangible, right? Some people learn visually, some people learn auditory, some are more kinesthetic where they like to touch and feel. And so if you want to get physical gear and physically plug the cables in, you can. But with things like Packet Tracer, you can build a topology like this. If you haven't seen this, this will be quick. You can take so down here on the, I forgot to add a layer. Okay, here's a new layer. So in GNS3, in Packet Tracer, in the bottom left-hand corner, there's options for, do you want a router? Do you want a switch? Etc. So you just click on that, and then you drag and drop the devices that you want. So maybe you want a multi-layer switch. Call it switch 1. You want another switch, so you call it switch 2, and then you want a router, so there's R1, you just name them whatever you want, R2, and then you have the ability to connect them all together, so you connect them here, here, Maybe you connect that guy there, put 2 in for ether channel that you want to practice with. Now that takes about 30 seconds after you've done it a couple times, just to drag in, and then you power on and you start configuring. Versus if you wanted to change your physical topology, you have to set your gear up, think about it, physically cable it, move it around. So nothing wrong with the physical topology, but I would encourage you to start with Packet Tracer, get really good at the configuration and the show commands, and then if you want the physical gear, you bring it in. My physical gear is on the other side of this wall, and I plugged it in. I plugged it in a couple times recently. One was for UDLD, unidirectional link detection, because the emulator couldn't support it in Packet Tracer and other emulators. So I needed it for that because I was doing a CBT Nuggets Encore course topic on spanning tree and detecting loops, and I needed that, so I used physical gear. And there's maybe one other exception where it was needed, but it's very rare that I would have to break out that physical gear for any CCNA topic, including wireless. I mean, with wireless, let's say we had a wireless controller. So in Cisco, they call it WLC. Think of a controller as the brains behind your wireless network. And then we have access points. We'll call it AP1, AP2. And they're connected into our switches. Maybe we have AP3 over here. And one of the challenges with wireless is that we need to have coverage. So if Bob, walking around the network, it needs to have good signal for his mobile device or laptop or whatever that mobile device is, anywhere he goes. And so what happens is these APs are getting their instructions from this controller. And if we need to change the channels for the frequency ranges of those APs, AP stands for an access point, a wireless device that's sending and receiving wireless signals for the benefit of our wireless clients on the Wi-Fi. It's a Wi-Fi function. So this wireless controller can communicate with all those, coordinate the channels, coordinate the strength, identify rogue with the right software involved, rogue access points that are showing up. And then these access points, if Bob is over here and he's associated with this access point builds a tunnel back to the controller. Think of a tunnel like a logical secret path through the network between it and the controller, and it takes all those signals and it forwards them to the controller, and then the controller can route them and forward them and process them as the traffic needs to go through the network. And so, what was I going to talk? Oh, yeah. So for building this, it's like when I did the CCNA wireless a couple of years, 3 years ago for CBT Nuggets, I literally bought access points, and then I got a software-based wireless LAN controller that was running in a virtual machine, and then I bridged them all together, and it was a pain because to get the physical access points and then to practice what the roaming looks like across the access points is tricky. In Packet Tracer, this whole topology with the wireless access points and a DHCP server and a server to handle IP addresses and everything else is probably 5 minutes to set up, and cost was $0 in dollars. So I strongly recommend Packet Tracer. If you're on a budget, Packet Tracer. If you're not on a budget, Packet Tracer. And then if you want to build a gear, you want to get some hardware because it's pretty inexpensive on eBay and so forth, you can practice and play with that. But I would do that as a second measure if you have extra time. I'm always about the Pareto principle. The way I understand it was he is an Italian economist, and he talked about the value. And he said that about 20% of the activities we do provide 80% of the value, and 80% of the activities provide 20% of the value. I'm all about focusing on the 20% that's going to give us the biggest bang for the buck. And Packet Tracer is one of those things where if you want to learn how to configure and tweak and create networks and route through networks and do layer 2 switching through networks and do wireless on networks, Packet Tracer provides a very reduced friction amount to getting to that point so you can do it, and it's free. Where physical is nothing wrong with physical, except it just takes a lot longer. And next time you boot up a switch, go make some coffee, because you power on a switch like a 3560 or even the newer ones, it's like it's taking off. So it powers on, goes through a power on self-test, and then by the time it gets up, it could take 2 to 3 minutes for that thing to fully boot, and it's loud. And so if you have a stack of those or several of those, that's not a real big benefit. Okay, so as far as building a network, please start with Packet Tracer, and then as you want to build a network, you could I would start with at least 2 routers and 1 switch at a beginning point, and that way you can glue them together. When I first, when I was a young man in what year was it? Probably 1999. Yeah, that's like 20 years ago. No, 21 years ago. Yeah, a long time ago. I bought my first routers. And this is when there was no emulation option. So I went online. I found when I say I went online, there wasn't much Google back then either. It was pretty much rough. So maybe I'm not sure how I found it. I found a vendor who was selling used routers. They were Cisco 4000s. It was a modular router. And I bought 3 of them. The cost was $5,000 for all 3. And when I got them, it's a lot of money. More money than I had at that time. I wasn't a CCIA then. I didn't make a lot of money then, but I thought I'm committed to this. So I need the practice and I need to go ahead and do this. So I bought them. When they came in, they had no Ethernet modules. So it was modular. So there was a power supply connector, a console connector, and that was it. And I was like, oh, like, how am I going to network these? I didn't have an Ethernet switch. I could use a crossover cable if I had Ethernet ports. So I spent several hundred more dollars, bought some used modules for it, and it was a learning curve. And then I got those going on, and I built them into a rack. And then in 2001, I eventually got my CCIE route switch, which I'm grateful for getting that. It was a lot of work, but totally worth it. And then I went on for a CCIE security in 2003. And for security, I bought more gear. So in those days, we had to buy gear. Today, please start with Packet Tracer, and then Viral. Viral 2.0 is going to come out soon, and it's going to be a lot better than Viral 1.0, which is Cisco's product. It's licensed for a year, $200, and you can just practice with lots of amazing technologies that would cost tens of thousands of dollars if you had to buy the individual gear. Okay, so let me scroll back up, and that was Andrew's question. What kind of physical lab should I start with? And I hopefully I answered that question for you. All right, and Norman's saying greetings from the Bermuda Islands. Nice. I've never been there, but I'm sure it's amazing. Okay. Motaz, you're very welcome. Just looking for my name on these. Oh, Oladeji, I think that's how it's pronounced. Oladeji. You know how it's pronounced. Thank you for the question. I appreciate you being here. You said you don't have a college degree. Trust me, that's very kind. Thank you. I appreciate that. It's very, very kind. I'll give you a quick backstory if you want it on me. I'll make it short. Famous last words. I was born in '64. I was third out of 4 children. All my brothers and sisters, my older brother and sister went to college, crushed it. My brother works for IBM, has worked there for over 30 years for IBM, just going through the ranks, and he loves it. I assume he loves it. He's been there for 30 years. And I wanted to take the fast track. And I learned some really hard lessons on that fast track. I thought, I just want to go out and I wanted to be wealthy as a young person. So growing up, this is probably very common for many people. I'm sure I'm not alone in this. My father was a principal first I started as a teacher in Ventura County, California, as a teacher. And then at nights and weekends and during the summers, I believe, he went to graduate school so he could get he went to go get his master's, which was required to become a principal. So he just ground away, kept on studying, became a principal, and then he was a principal for the remainder of his teaching career. And he was very prudent with money. I mean, we never went hungry. I never recall ever. We had a house we lived in. It was great. He protected us, is what he did, which is, pretty amazing. So on a very limited budget, he protects us. So growing up, I thought, what I want to do most of all is I want to make some money, a lot of it. And then I realized very quickly that there's no shortcuts to doing that. And I went into sales for a while. I sold insurance. I sold cars. And I realized that I wasn't good at that, and not without remorse, because I found my niche. And so I was working as a cashier at a hardware type store in Ventura, California. And there was a guy who came in to repair the cash registers, and I thought to myself, wow, this guy looks like he has a nice car. It didn't have rust on it or anything. And he has a silver briefcase, like a James Bond briefcase. He looks like he doesn't have a boss. I'm sure he did. But he was in there working on the stuff, and I thought, I'm not sure what he does or how he got that job, but I bet I could do that. And so on the TVs, it's a true story, on the TVs that were across from us from the cashier row, there was these commercials for Control Data Institute. This was like 1985, 1984, and these commercials would come on, and so I called them, and I went to down to LA. I lived in Simi Valley at the time, so I went down to LA, and I got a student loan, a loan for it was close to $6,000 as I recall. It might have been a little more, and I got a loan. I went to this school for a year, and I learned all about electronics, and it was their brand new microcomputer technology. I learned about resistance and capacitive circuits and all these details that I've probably never used. But 8 months into this 1 year long course, I got called Mr. Polite. He was if anybody out there knows Mr. Polite, who worked at Control Data Institute in the mid 80s, I think he's passed away by now because that's been a long time ago, and he was an older gentleman at the time. He was so mean because he cared. He was so mean, whoa, what's this? And he wouldn't give us 1 inch ever. And I thought, this guy's such a hard nose. Why is he being so mean? It's because he wanted us to succeed. It's the same reason I want you to succeed. Whether you're at CCNP level or CCI and you're working on something new, or you're just getting into CCNA, I want you to succeed. And so Mr. Polite would not give us an inch. He forced us to learn. If we made mistakes or weren't applying ourselves, he was going to call us out on that. And about 8 months into this 1 year course, they were Electronic Data Systems was interviewing. That was an old company now bought by HP, but it was Ross Perot's old company back in the day. And they were interviewing for candidates for field technicians. And they said, hey, they're interviewing for people, field technicians, we'd like you to go. And I said, hey, well, I'm not done. I got 9, 10, 11, 12. I have 4 more months, counting bits for subnetting. I've got 4 more months. I'm not done with school yet. And they said, you don't get it. Mr. Polite was like, you don't get it. You're not in school so you can become a master at being in school. You're here getting training so you can apply that skill in a real job and then get more experience on that job and just keep on moving. And I thought, oh, okay. I didn't know what I didn't know back then. So I interviewed with Anita Martinez, went through, some of the details for that are on the my YouTube channel, my career. So I'll leave them for that. So I got this job and started working with electronics and microcomputers, as they used to call them, PCs, with the IBM PC and then the IBM AT and the IBM 386, which people thought, oh, it's going to take over the world, and then local area networks with coax cabling and Novell, and that migrated onto Cisco, and then Windows, and the story just kept on evolving. So where was I going with all that? Oh, no college degree. I wanted to take the fast track to success and wealth. I have no shame in saying that's what I wanted as a young person. I realized along the way that the way to actually have a great life is balance and consistent movement forward. That's it. I could right now look at so many things and people in my life or in the world and say, oh, I'm so nothing compared to that. Easy. But what I do is I just I have a whole channel on, how to be successful. And it's basically identifying what the heck you want, what you're willing to trade for that. Meaning I'm going to study so many hours a day, or I'm going to do this and this, and just keep progressing and enjoy the journey. See, it's not like, oh, misery, then yay, success. It's got to be a little bit of joy as you're pursuing and seeing measurable results. Like, oh, I'm going to study this topic and I don't know it very well yet. And you study the topic and you're like, well, I know it a little bit better now. And the next time you study it, I know it a little bit better. I'm going to lab it up and just continue and see that growth. If we can see that growth in ourselves, that's going to give us the motivation to continue. And so I know I'm so fortunate. I know my wife will be the first one to tell me, Keith, you have an overabundance of luck and fortune, and just out of just pure dumb luck. And it's true. I do. I know that. In addition, I think anybody who applies those same concepts of identifying what you want, working consistently, measuring the results, spot by spot as you go on further and further, it's going to be better than if you did nothing. So whether you're lucky or not, we can move the needle, which is my goal in life these days, is to move the needle. I want people to change, not a whole bunch, just a little bit. And then in 5 or 6 years, if you're just starting the CCNA journey with me, in 5 or 6 years, when you've got your CCNP and you've got some experience, and maybe you're working on or you have a CCIE or 2, or you're working with other vendors like Checkpoint or Palo Alto or other vendors with great products as well, I would love nothing more than to meet you or contact you online and have you say, Keith, oh my gosh, thanks for starting out this career for me, or thanks for helping me along the way. That's it. That's my whole motivation, is I would love to help other people just move the needle a little bit, and everybody in this channel can do that with me. All right, off my soapbox. Measurable move. Okay. So college is great. If I had to do it again, I probably still would not go to college, just because I was a little bit rebellious as a young person who had an inferiority complex, which actually carries on today a little bit. So I'm just willing to work a little bit harder than someone else who may not have that motivation, and that makes all the difference. Okay, so that was based on that one question. Rant much? No. Yes. All right. Omar is asking, hi Keith, can you give an example of VLSM but start from low to high for /24 subnet and get the 2 WAN links from the /30? Here's what, Omar, great question. In my entire career, I've always done subnetting, custom subnetting, and planning them out. Well, now I use calculators, right? Because there's no reason to actually do it manually, unless you're in a certification environment. But I've always started off with the biggest subnets first, working down. So here's my request to you. If you would like to do the custom subnetting like we did in the previous Subnet Saturday and work from low to high, go ahead. Knock yourself out, because the process is going to be the same. And I just never do it from high to low. I believe it could be done. And that question last week made me think about that. But I always do it high to high, low. So Omar, if you want to post that as a request in the Discord channel, let's go ahead and do it. And we can have people give feedback on it and put in their results. And if you're going to start off with the slowest, the tiniest, you'd start off with the /30s. Take that range, which would be like 0 through 3. And then the next subnet would be 4 based on that /30 mask. And then you'd do it again, and then the next mask, and the next mask based on how many hosts you need. So I believe the process would be the same, and I would encourage you to do that in the Discord channel so we can all see it. All right, Nicholas, welcome. Nicholas is asking about the switches and routers features you're talking about for the CCNA lab. Could you tell which chassis devices versions would support those features? Oh, great question. It really depends on the iOS that's running, the software that's running on those switches and routers. So if you go to Cisco's site, I haven't done this in the last 6 months, but if you go to Cisco's site and you look at the feature set for which iOS features support which functions, then you can say, oh, this switch with this image supports dynamic ARP inspection, DHCP snooping. And so if you're buying it on eBay or somewhere else, you can look at the output, see what version it is, then go to Cisco's website and search for that version and feature set. And there used to be a really concise page. I don't have the URL for it. Perhaps somebody in the Discord or here can find it, that allowed you to go to that version of iOS and then, or a feature set navigator, I think it was called, where you could put in the features and it would tell you what versions of software have it. Usually Enterprise is going to have most everything, but I would also just verify that. And that way, when you're searching for kits or hardware on eBay or wherever you're going to buy it, you could take each version of iOS, verify what features exist, and then buy it or not buy it based on if those features exist. Because if you buy a Cisco router on eBay, it's not through an authorized reseller usually, and as a result, you're not going to get support from TAC, Technical Assistance Center from Cisco, and you're also not going to have the rights to download updated software for that device. So those are all challenges that come if you don't get the right software on the iOS device. But a really great question. I appreciate the question. Paul CCNA is asking, is there a controller in Packet Tracer? There is a wireless LAN controller in Packet Tracer. I know because I included it in at least one of my CCNA, in at least one of my CCNA content at CBT Nuggets. I actually labbed it up. I thought to myself, okay, I need to teach wireless LAN controller and associating with access points and getting a client connected, having a DHCP server. What is the most effective way that a learner could realistically do this? And the answer was Packet Tracer. So I demoed it in Packet Tracer. And I also have, at CBT, I have a whole, like 6-7 videos in a Packet Tracer section that walks through how to set it up, which is pretty straightforward. Just go to neticad.com, download it, get a license for it free, and then start dragging those devices out to the network topology and go to the CLI tab and just start working with them. So thank you for that question, Paul CCNA. All right, scrolling down to, Mahir is M-A-H-I-R. So Mahir is asking or stating, for Viral, which is the Cisco product that's licensed for 1 year for $200 for the full year, you still need a good server to run that on. That is true. So whether you have a dedicated piece of hardware that can run the free ESXi from VMware, or if you have a PC that has VMware Workstation, or if you have a Macintosh with VMware Fusion, you're going to need some pretty good hardware to run that. So I just ran that actually yesterday. I hadn't touched it in a while. I have a license for it, so I installed it, configured it. And version 1.6, which is the current flavor as of today, it's not too straightforward to get the whole thing going. And my anticipation is that with version 2.0 of Viral, which I hope to be released anytime now from Cisco, I don't know if they're going to upgrade me or if I have to buy another license, but either way, hopefully it'll be more straightforward and less friction for a person to get into it. But either way, currently, you definitely need some horsepower to run it. Probably at least 16 gigs of RAM, and if you had an i7 processor, that wouldn't hurt. Although you could probably do it on less, but you're going to need some RAM and CPU to make that happen. Great comment. Thank you, Mahir. All right, he's also saying, M-A-H-I-R is also saying, I am following you since 2011 when I was with INE. I still love your security videos you made for INE. Well, thank you. I had a great time at INE. That's Internet Network Expert, and that was the Brian McGann and Brian Dennis, who are the two chief architects there. Brian McGann is still with them. They got purchased or enveloped in a larger company. I've got several friends that work there. I like INE. If you're interested in CCNA training, I have zero reservations about sending people there. They also do some CCNA level stuff as well. So thank you for that. I'm glad to have a friend from 9 years ago still with me and now helping out in the channels. Fantastic. Okay, Raging Crypto is asking, hi Keith, I'd like to know what is the tiebreaker in STP? Spanning Tree Protocol. If there is one switch with two switches connected to another switch, but all four switch IDs are the same. Great. So that's a lot to unpack there, but let me tell you how it works, and then it'll answer that question, I believe. The first question about who's going to be a designated port or a root, let's start with root ports. If I'm on a non-STP route, let me go ahead and bring this up, and we'll draw it out. Not only will that give us a chance to draw it out, it'll give me a chance to think and also to present this appropriately. And let me bring up another layer, and let me get some pen out here. Okay, so actually, let me see if I can look at your question here. All right, so it's too much for me to unpack in the comment right there, Raging Crypto, but let's go ahead and make a scenario like this. And we'll put a couple there, a couple there, a couple there, and we'll call it switch 1, 2, and 3. And let's say that switch 3 is the root. So this is a spanning tree question, everybody. If you haven't yet joined us for our spanning tree discussions, we have some pretty fun ones and very, very thorough ones here in the playlist, the master playlist on this channel. So take a look at those if you want. So let's imagine that switch 3 is the root. He becomes the root, he or she becomes the root because it has the lowest bridge ID among 1, 2, and 3. And the bridge ID is 3 parts. It is the priority and the base MAC address, which is not the MAC address on an interface. It's the base MAC address on the platform as it ships from Cisco, plus the VLAN ID. All right, so switch 3 won, and he's super happy. He's the root. And let's go ahead and put that in yellow. Congratulations. You are the root. All right, now the question is, switch 1 and switch 2 are not the root. And so they need to identify their root ports. So root ports only exist in spanning tree on non-root bridges. So root ports, how do they decide, switch 1 and switch 2, how do they decide individually on their own which is the root port? And the answer is lowest cost to root. So let's imagine that all these links are the same, whether they're fast Ethernet or they're all gigabit let's imagine they're all the same. And let's focus on switch 1 for a second. Switch 1 says, okay, it's the lowest cost to get to the root. And it says to itself, self, says switch 1, both my interfaces, I'll call this interface 1, actually interface A, I will use 1. Actually, to make this very clear, I will use interface 6 and 7. And over here on switch 3, the root, I will use 10 and 4. That way we can make this very clear how the decision process works. So switch 1 says, what's my lowest cost to get to the root? And it says, well, it's the same cost going through interface 6 and interface 7. Same exact cost. So that one's out. The next one is the advertised bridge ID. So in this case, the root bridge has a bridge ID. It's this guy. He's advertising it down both ports. So if switch 1 was connected to multiple switches and they all had good possible paths to the root, it would say, oh, if it's a tie, like do I go through switch 9 or switch 10, if both switches have equal cost from switch 1's perspective, it would choose the one that has the lowest bridge ID. But in this case, both these links that are going to switch 1, they are both advertising the same exact bridge ID. So the bridge ID is the same for interface 6 and interface 7. So the next thing that switch 1 is going to consider as it tries to decide which root port to use is lower, I'll say lowest, L-O-W-E-S-T, advertised. Let me make sure my face isn't on there. Yeah, my face is on there. Hold on a second. Lowest advertised port priority. And so let's imagine that now we're talking about the root advertising here and here. If the switch has a default priority, which I think is 128 by default on each of its ports, it's advertising a priority of 128 down both ports. So switch 1's like disappointed. It's like, well, these are both the same cost, 6 and 7. The advertised bridge ID coming down from switch 3 is the same. It's the same bridge ID of the upstream switch, which is the root in this case. And the priority is the same. 128 here, 128 here. Now what? Then it's the lowest advertised port ID. And I will circle that. Yeah. So lowest advertised port ID. So basically, switch 3 is advertising a port ID of 10 on this port and a port ID of 4 on this port. It's advertising those. And that's why I have this keyword here, advertised port ID. And just like golf, spanning tree is lower is better. And that way, switch 1 for its root port would choose port 7 because that's where it heard the lowest advertised port ID based on all the other factors being equal. They were both the same cost. They are both coming from the same bridge ID, so there wasn't a lower one there. They were both advertising the same port priority, and the tiebreaker was the lowest advertised port ID. So port 7 would be used. Port 6 would be in a blocking state, or in spanning tree officially, they would call that discarding state, but it shows up as blocking with the show command, and it would show up as an alternate port, meaning if that primary port is not available anymore, that alternate port can go ahead and start forwarding if we're using rapid spanning tree. If you're using traditional spanning tree and you lose a port, you can use uplink fast. That would give us the same benefit. And that is the answer to that question. All right. Thanks for that question, by the way. Let me see if I can scroll up and see where I was. Give me one more moment. Okay, wow, way up there. All right, so moving forward. Okay, Flux Polarity, which is a great handle, by the way, says, Keith, thanks for all your video tutorials. Question, I'm using a laptop. It's connected to the internet using Wi-Fi. Can I use Wi-Fi internet to act as an ISP in Packet Tracer? That's a great question, Flux. I don't know. I think there are options for integrating your packet tracer topology with other packet tracer topologies. So I have not experimented with that yet. If you want to join Discord and put that as a question, if somebody else doesn't answer that, and you can post it there. You can also do an @Keith for me, and that will get my attention, and I can look into it as well. So I don't know the answer for that, but I'm interested in looking into it. Great question. All right, Daniel's stating that there are some limitations with packet tracer. We just exploited on Discord, IP access list resequencing. Okay, well, if again in Discord, if there's like a question and answer and you want me to jump in to any of those discussions and give my 2 cents, I'd be happy to do it. Just do an @KeithBarker and say, hey, here's this discussion in that same channel, and I will get some attention on it. I love it when people are chatting about how things work. Packet tracer is a simulator. It's great for most of the basics that we would need for CCNA. It's not perfect. It doesn't have every single possible command, but it's more than enough to really learn Cisco networking. Okay. All right, Norman has a question about CCNP Encore really quickly, 35401. What I would do if you're considering taking any exam, just download the blueprint, look at it, go through each item and say to yourself, how well do I know this on a scale of 1 to 5? And if it's a 5, great. If it's a 1, I would brush up on that topic before you go take the exam to make sure you're good at it or good enough to pass an exam on it. And I would say if you're like a 3 or less on any topics in the blueprint, especially one that says configure or verify, I would probably brush up on that before you take the exam. So I haven't seen the Encore exam yet. Oh, by the way, I'm going to be sitting the CCNA exam probably in about a month and a half. And the feedback I've gotten on it is that it's incredibly tiring. It's 100 plus questions, like 105-ish or something. Haven't taken the exam yet, but the feedback I got, let me just open the kimono here for a moment. I've seen a lot of videos regarding people and their experience. Now, there's an NDA, non-disclosure agreement, that you're not allowed to talk about exact questions. Great. So we should all abide by that, and that's part of the rules on Discord as well. Don't reveal anything that Cisco doesn't want you to reveal. But if there's a topic, a blueprint item, and you want more information on that blueprint item, or we should focus on that blueprint item, that's fair game. So there was it's great. I will always tell you the truth on this channel about the technology, how it works. My goal is to make sure you're comfortable with it, encourage you, motivate you to get hands-on practice and learn the technology of CCNA, and then keep on those skills, keep them moving. I saw some videos that were very, very great about the exam. About, hey, this section of the blueprint, really need to know it. This section, kind of casually, and some ideas about that, fantastic. And I saw other people, and these are, I will not reveal any names. I saw other people that were justifying something that probably is not in the exam, but that they have content or training for, that they wanted to justify why they were still training on it. Maybe a technology or something that's casually mentioned or not mentioned at all in the new blueprint or the new exam. So I'm grateful for people who are willing to share their experiences and share within the limits of the NDA and their opportunities of improving for the exam. And my goal is, and I've got a lot of new ideas, by the way, based on watching all these videos of new topics that I thought, oh, you know what? That would be great for a live stream. Oh, you know what? That would be great for a live stream. And so I've got maybe 20. So that could be, I do streams on Wednesday afternoon Pacific time, so get out your world clocks. Wednesday afternoon at 4 p.m. Subnet Saturdays is Saturdays at 11 a.m. and then CCNA Sundays is also 11 a.m. on Sundays. And so I've got maybe 20 plus topics that I want to add for CCNA that we can do on Wednesdays and Sundays. And then for subnetting, I think probably within 2 or 3 more weeks of one a week, we'll cover most of the core topics, where anybody could go to Subnet Saturday and just say, oh, got it, and go down the list and be very comfortable with subnetting. So regarding challenging an exam, make sure you look at the blueprint, and if you feel like you're comfortable with the concepts, I would say go for it. Okay. Ed, you're welcome. Thank you very much for that comment. And Mahira is saying, I can say that I did my CCA just because your videos motivated me and taught me the technology in the easiest way. Oh, that means a lot. Thank you. That's awesome. Well, way to come back and support other people on their journey in CCNA, which is the folks of this channel. I really appreciate that. All right, MIM. Does EXI host connected to real switch? Okay. So ESXi is a free, if you buy a standalone version from VMware, that's their standalone hypervisor. And if you're connecting it to a real switch, a physical, so like the virtual to physical, it would be, you could do trunking to that switch. So on the switch side, you say trunking, and then on the VMware side, in the virtual switch, you'd specify that you're supporting multiple VLANs, and that way you could actually carry multiple VLANs between the inside world with the EXI host to the outside world. For CCNA, I wouldn't expect people to have to do that, but that's how I would do it if I wanted to carry multiple VLANs out. Or if you wanted to have everything just in that virtual environment, you might have one interface or one VLAN that goes out to the outside world, and then all the other VLANs are mapped internally. That would work too. MIM, great to have you here. It's your words and your ideas that help me change my music up a few times, and I also appreciate all the comments. Okay, great. Angela's asking about wireless topics in CCNA. Which is the difference between? Great. I'm going to hang on to CCNA wireless questions, and I would like to do a few live streams on that to go ahead and elaborate, make sure you're comfortable with controllers, access points, associations, and the wireless technology you can use, such as the encryption, the security with WPA, WPA2, WPA2 personal. Also, Angela, if you would, if you're on Discord, which I'd love you to be, if you go ahead and post that in a suggestion for a video, and that way I won't forget it. Like, hey, let's do a video on this or a live stream on this. Okay. Daniel, thanks. Trying to do the VLSM from small to large. If you post that in Discord, I will actually do the exercise and post my results. Because I've just not done it, and I don't think I've ever done it. I don't think I've ever done VLSM starting with low going to high, and that's probably why I'm not a big promoter of it. And if you're doing it with a piece of paper or a VLSM calculator, starting from large to small is going to make sure you have enough room to begin with. And it's always been the way I've done it is start with your larger subnets and work smaller. Okay, IPv6 addressing. John Kennedy, you, my friend, are in for a treat. That is coming. So IPv6 addressing was based on the feedback I've heard, and again, I haven't taken the exam yet, but there is a pretty hefty section for IPv6, and let me share with you this. It's like, Keith, what is this? This is a chalkboard. Okay, let's imagine we have routers. No, router 1, router 2, router 3. Make sure my mic is over here. And they are connected. And the actual connectivity, maybe we have a slow link and a fast link. Let me change this. Yeah. So let's imagine this is fast Ethernet, and this is gigabit, and this is, let's call it slow. S for serial, slow. And if it's IPv6, and we have networks hanging off here, so we have network A, and network B, and network C, and there's no dynamic routing protocols. So for CCNA, they cover OSPF version 2, which is OSPF for IPv4, but on the blueprint, it doesn't have anything about OSPF version 3, but it does have quite a bit on the blueprint about IPv6 and IPv6 routing. Let me grab the blueprint. All right, thanks for waiting. So in section 1.8, sorry for the paper noise there. Yeah, so in section 1 of the blueprint from Cisco, 1.8 says configure and verify IPv6 addressing and prefix, which is the network portion. And then 1.9 is compare IPv6 address types, global, unique local, link local, anycast, multicast, modified EUI64, which I intend to cover a lot of that in our subsequent videos here as part of this channel. Also, our CBT Nuggets course totally crushes all this, by the way. Everything on, I saw Jeremy's video as well, and he went and took the exam, wanted to make sure that our CBT Nuggets content was thorough enough to master the content to the level we could pass the test as well. And he said, thumbs up. it's got everything that's required. Although he said it was a taxing exam. And then going down to 1.11 is our wireless. And going down to section 3, more IPv6 here, we have section 3, which includes, 3.3, configure and verify IPv4 and IPv6 static routing. And I can tell you that at the course they did at CBT for CCNA, we cover it extensively. And so I'm going to include also here on YouTube, we'll have our instructor hours, like live stream. We'll focus on IPv6. But maybe you have a situation like this where all these networks are IPv6 and they want you to put in static routes that would allow full connectivity between networks A, B, and C using the most optimal paths. So for R1 to go to so for network A to B, I would use a different color here. Let me back that off. So from network A to B, I need lighter color. Still playing with my pens. Thanks for your patience. So from A to B, the path would be R1, R3, R2, because that's going to be the faster path. We want to avoid that 1.54 megabit link if that's the case. And then so basically the concept would be full connectivity between A and B, I didn't put C over here. Between A and C, A and B, B and C, we want to implement static routing. So we're using the optimal paths. And the only way a person could do that is to have some practice in doing it. So you'd have to plan it out first. Like, okay, what is R1's decision going to be to get to network B? And that static route should go this way. I'm just saying from this topology. And for router 1 to get to router C, the route should go this way. And that's it from router A to both those networks. Then from router 3 to get to A and B, it would go this way and this way. And then for R2 to get to those two networks, it would be this way and this way, avoiding, again, that slow link. And if they wanted a backup route, in case this link goes away, then we could have a floating static route for IPv6. The concept is the same for IPv4 and IPv6, a floating static route that would go over this link if needed. Now, that would be based on their requirements. If they didn't say anything about needing that, the answer to this scenario with IPv6 is understanding how routing works, how to look at the routing table, and then how to configure static routes for IPv6, which my understanding is more than fair game for that exam. And that's why I got like 20 new ideas of things we would additionally cover. So that thing I just did was just out of my head. And we'll build some labs like that. And I'm also thinking about building Packet Tracer so that as we do a few of these, like any of these demos that I've done through these series, usually there's demos on implementing commands, they can be done in Packet Tracer. And so I might just sprinkle in some Packet Tracer from the ground up so that you can get more comfortable with using it. Like in this topology with three routers with IPv6, drag, 3 routers, auto connect tool, boom, boom, boom. And then maybe put a PC on each subnet, put in an IPv6 address. The addressing part might take a few moments, but that's a great way to get practice with all that. So thanks for that question. And that was from John. So thanks for that request, John. And let's see here. Wilton is asking, hi Keith and the community, what is the use of Sniffers and how is it configured, please? Great question. So in a production environment, there's lots of ways. Let's back up a little bit. Let's use this device as an example. This is a little ASA, but all these ports can be configured as switch ports. Actually, these are layer 2 switch ports on this little ASA, and we carve out VLANs on the inside. That's a whole nother story. So if we wanted to eavesdrop on the network, I call it eavesdropping, but sniff, we would say to the device, see this port right here? Take everything on this port and redirect it out this port. And then on this port, we could have a device with a protocol analyzer that's capturing the packets like Wireshark, which is free. You should do Google for Wireshark. It's a free download. And we could have a PC connected with Wireshark on that port, just telling it to listen and eavesdrop on the traffic, and it would capture all the traffic that computer is now sending or receiving on that port. Also, that's called span. In a switched environment, it's called span, meaning switched port analyzer. There's also the ability to tell a switch that, hey, take all the traffic that's going into or out of or both VLAN 50 and copy it to that port where that protocol analyzer is hanging off of there, that computer with Wireshark running, and that will allow us to analyze that traffic. So I'll tell you what I've done for a long time is I grew up after, like, when GNS3 was first coming out, it was like version 0.08 or 0.8 or something early. I thought to myself, this is the best thing ever because I don't have to buy these racks and racks of switches and devices. I can use GNS3, and even though it's not perfect at that time, it's gotten a lot better since. I don't have to have all that physical gear. I also learned that in GNS3, along with other simulators, you can actually integrate the capturing of packets. So you could have router 1 and router 2 connected over either a crossover cable or both connected to a switch. You could just right-click in GNS3, right-click on that link and say capture packets if you installed Wireshark, which is free. And Wireshark on that same machine running GNS3 would capture all the traffic on that link. And that way you could analyze it and look at it and search through the packets and see what's happening with it. So regarding the use of Sniffers and how it's configured, if you do it in a physical environment, on a switch, it's going to involve span. On a Cisco environment, switch port analyzer, where you're copying all the traffic from either a VLAN or a port over to the port where your computer is that's running Wireshark. Or you can also do this thing called remote span, where it takes the traffic off one switch and ships it over to another switch, over to a port, so you can analyze the traffic. But the easiest way, if GNS3 is running, the easiest way in GNS3 is just to right-click, and it automatically has the option for start capturing packets with Wireshark. And that's if you have Wireshark installed. I'm going to hit this button, which turns on my fan. It's getting a little warm here in Vegas. It is, what month is it? It's March 7th, and 2020. And starting to get warm outside. All right, so thanks for that question. That was from Wilton. Thank you. Oh, and John Kennedy just confirming that IPv6 questions are throughout the practice exams. Good. And it's based on the feedback I've had, IPv6 is going to be more heavily hit. In the past, like with old CCNA stuff, it was touched on, like hinted at, and now it's going to have a fair shake based on the objectives in the blueprint. Okay, Dan is asking, can we get one more example for the reverse engineering? Dan, yes. Dan, if you would like to, I'm going to answer a few more questions. If you'd like to post, give me an IP address. Any IP address with a mask. And let's make it not a clean octet, like something other than a /8 or a /16 or a /24. Something with a non-8, 16, or 24-bit boundary, so we have something to play with. And then also make sure that the last octet for the computer is odd. And that will make sure we have at least one host bit on in the host address. Because that's one of the rules for IP addressing. The host portion, the host bits at the very end of the IP address, they can't be all on. That's the broadcast address. And they can't be all off. That's the network address. So they have to be at least one bit on and at least one bit off in those host bits. So Dan, if you're up for it, if you're still around, go ahead and do an @Keith. Give me an IP address with those considerations. Non-clean octet boundary and an odd last octet with the odd number in the very last position. And we'll do one more. Yeah, love to. Okay, moving on. All right, so here looks like a statement. Thank you for that. Let's see here. Moving down where my name is showing up. Andy's saying you have an amazing skill to not be shy when you're live teaching other people without messing up. Thank you. I appreciate that. I'm so human. I'm about as human as everybody else. In fact, I'm 100% sure that's the case. And I have practiced a few things over the years, so it gives me a little bit of a comfort level. I feel pretty comfortable that with whatever happens, based on the concepts I'm teaching, that we can just follow those through and they'll be fine. But thank you for that. Okay. All right, we talked about the sniffers. Yeah, Maher is asking, how do we practice DNA? Cisco's DNA Center, that's a bit tricky. At the CCNA level, it's mostly about understanding being aware that that exists and not really configuring it. So as we go forward, Meher, I'll give that some thought. If you would put that in Discord as a request or suggestion, and let me find out how somebody who doesn't have, oh, I know how. So for DNA, Cisco has something called dCloud, which is free, and they also have something called the DevNet Sandbox, and both of those options have some features regarding DNA Center. So that would be one way, but I will include some of that coming up in live streams and also give people some clean paths on how they can practice it without having to buy any kind of serious hardware to get there. Okay, great. Yes, Andy says that I'm near the 100K subs milestone. Yes, it's only taken me since 2009. I believe my first video was 2009, and I think it's now growing at about 2,500 a month. So that's you, by the way. So I've got a lot of old videos out there. The technology doesn't change, so the technology is still good. And I looked at one on reverse engineering an IP address, and I have an old one from like 2013, I think. I look a lot different. I feel a lot different then. I sound a lot different, but same technology. So if you want to check out that video as well. But thank you very much on recognizing that. So I imagine by the end of April 2020, I will be at 100K. And financially for me, that doesn't mean anything. But emotionally, as far as helping more people get their CCNA, and also the people who have their CCNA or are coming back to help other people, that means a lot. I really enjoy the ability to make a difference. And we're doing it right here, right now, you and I, everybody in this room. Thank you. Okay. All right, MIM, if you'd put that request in Discord, that'd be great. Regarding a WAN link redundancy on a firewall or layer 3 switch. And, okay, Raging Crypto saying, hey, how do I find Keith on Discord? If one of the moderators or somebody could help with that, I have this icon that says OG of IT. So if you do a search for OGIT_Keith, I think it is, or you do a search for Keith on the Discord channel, that should find me. And if you don't, you can post that as a general question, and one of the moderators will help you find me. Okay. That was a couple of questions from people. And looking for any last questions. Regarding sniffing, can you integrate pfSense in a Cisco environment? pfSense is a free for a certain quantity. I don't know if they have a corporate version of it, but pfSense is a very detailed firewall. It has lots of options. And can you integrate that in a Cisco environment? The answer is yes. You can put pfSense in any environment, and it would do the functions that pfSense, this firewall, has for it. So a lot of times in most environments, you're going to have lots of different gear. Like there's a lot of Cisco shops that don't use firepower for their next generation firewalls. They use Palo Alto, or sometimes the company from Israel. Why am I forgetting them? Checkpoint, yeah, as their solutions. And any solution is going to be fine as long as it works and functions. So we're often going to find mixed environments with different gear. And Dan, I don't see a follow-up question with an IP address. I think we had a question earlier. One more example for reverse engineering. If you still want to see that, Dan, throw me an IP address before we finish up, and I'd be happy to do it. All right, Flux Polarity is saying, just want to thank you for pointing out the power of block size. I understand subnetting easier. Thanks, Keith. You're very, very welcome. And the reason we circle it, we did our video on block size, and we circle it like a square. That last bit of the mask that's on, that's also the block of addresses that it's representing a block of addresses that we can use in that subnet. So you're very, very welcome. All right, I don't see another example request from Dan, so he may be gone. Okay, so if you have other requests, the things you'd like to see or things you'd like to work through, we can certainly do that in the Discord server. It is, let's see, it's almost 1 o'clock Pacific time, 12:50, so that's 11, 12, almost a 2-hour stream. But I've had a lot of fun. So we covered most of the meat of the content, which was how to reverse engineer what subnet a client's on based on its IP address. And that took the first hour, and then we spent the last hour here focusing on just some Q&A. All right. Thank you, everybody, for joining me. Our next live stream, as a little heads up, is tomorrow. It's for CCNA Sunday. I've been teaching for a long time. I've worked in the industry for a long time. I love it. It's like Tinker Toys, putting all these pieces and parts together. And then as we apply software-defined networking and network automation to all of it, we're still using a lot of those technologies, and we have to understand how they work. So everything we're learning, there's nothing that's like, I will never use that ever again. It's not like me in my Control Data Institute days in the 90s, or the 80s rather, where I was learning to read the resistance codes on a resistor, the color codes, and determine, oh, that's a XX ohm resistor, which I've never used. All of this stuff that we're learning regarding Cisco and reverse engineering an IP address and how to configure a router and reading a routing table and layer 2 switching and trunking and VLANs, all the rest, that's all going to be serving us for the rest of our IT careers. Because if we do start automating all of it or portions of it with automation, we're still going to have to be aware of those scripts that are being pushed down or how the controller's talking to those devices so the concepts don't go away. Oh, great. Dubon's asking, can you please explain what is this Discord? So about 4 weeks, I'm so behind the scenes. I'm learning. I'm such a baby. About 4 or 5 weeks ago, somebody chatted to me and said, in the live stream, they said, and if this is you, thank you for the recommendation. They said, hey, why don't you set up a Discord server? And I thought to myself, I've heard of the word Discord. I know some people have a Discord server. I don't know what it is. And so I started Googling and did some research. And what a Discord server is, it's free. You join it and you set up yourself a handle, whatever you like to call yourself. And there's Discord servers for different topics from different people. So you might have a Twitch gamer who streams Twitch his or her favorite game several times a week. And they'll have a Discord server where people as fans can jump in ask questions, talk with each other, make requests, kind of like a community where we can hang out. So with the live stream, we have this chat we have here, which is fairly temporary as long as the live stream's going. And then there's chat messages below, or discussion messages that we can ask questions, things below, but that's also kind of static, not too interactive. And I do go back through those. I look at those a couple times a week. But Discord is like a separate, think of it like a way for this community, everybody who's working on CCNA or everybody who wants to come back and help others who are working on CCNA, where we can all get together and chat about ideas or questions. If you have requests for videos, it'd be a great place. It's simply a place to hang out when you're available. Now we have like 10 or 12 moderators who volunteered to help, which I'm so grateful for. And all I ask of everybody is to check out the rules when you go in. There's a rules channel. You just look at it and agree to the rules. And if you're okay with that, which includes what the rules are, just go ahead and join and ask questions. So if you have a question regarding MPLS traffic engineering, that would go in the other section. You have a question about spanning tree regarding CCNA, like the ones we covered today, you put it in. There's lots of people who are going to be answering that and feeding it back and giving their opinions and answers. And if you ever have a qualifying question, the moderators are so great. They'll just say, hey, Keith, check this out. Or answer this if you would. Jump in. Or you can do it too. Everybody on the channel, on the Discord server, which again is free, can go ahead and ask questions. You can. That's the best way to contact me, by the way. Just do an @Keith. I think I don't @Keith myself, but on the Discord server, I think I'm pretty easy to find. And if you just do an @ and either OG of IT or @Keith, you think either one of those is going to pick me from a list. And then you can send me a friend invite for the Discord server, or you can just send me a message. And every time I jump on, those are highlighted for me so I can see them. So that's what a Discord server is. New to me, Chuck Keith, who I work with at CBT Nuggets, I think he's got thousands of people on his Discord server helping, talking, all these good things. And I'm just new to the game. Oh, Dan has an IP address. Rockin'. So thank you, Dan, for jumping in. Let's do one more reverse engineering. If you need to bolt, I totally get it. If you want to hang out here and listen to the sound of my voice as we do one more reverse engineering, I'd love to have you stay. Either way, it'll be recorded. If you need to come back, you can look at it later. That's great. Let's go to the topology. And let me clear off and bring the mic over. And let's bring up another layer. Okay. Well, Dan, thank you very much for that request. I'm going to look at that request so I can make sure I see what it is. All right. Let's jot it down right here. We have a PC. This isn't just any PC. Let me bring up my face as well. This is Dan's PC, because this is his question. Dan's PC, that could represent a mobile device on a wireless network. It could represent a Linux box, a Kali Linux box, Ubuntu. It could represent an Apple computer. It could represent a PC. It could represent a printer, maybe even. Some device that's on a network that has this IP address courtesy of Dan, and that IP address is 10.33.73.213. Oh, I think I'm in love with this address with a /29. Let me just double check that. 10.33.73.213/20. Okay, so I'll keep my face close to the mic so I can be heard. All right, well, I think there were some rules to this game of what network is this? That's the game we're playing. The game is called What's the Network? And I'll put net ID. So think of the net ID like the street name. What street is this that Dan's PC is connected to? And the first rule is get the block size. And the block size is based on the mask. So we'll go ahead and put our values here. 1, 2, 4, 8, 16, 32, 64, 128, and 1, 2, 3, 4, 5, 6, 7, 8. In the heat of battle, make sure you have 8 positions there. If you skipped one, you have like 7. It's like, wait. So that's 8. And this /29 means that the first 3 octets, the first 3 sections of that mask are all on. So we're going to focus. This is the 3rd octet going that way, and this is the 4th octet or 4th byte of data after that period right here going this way. So let's put in the mask in binary. So we have 24 up to this point, and we're going for 29. So 25, 26, 27, 28, 29. That is the dividing line right there. Boom. Between network on the left and host bits on the right. So that's net, that's host. And so far so good. And then our question here is block size. So we'll go ahead and we will put a block around the block size, which equals 8. So let me check my work. 25, 26, 27, 28, 29. That's the least significant bit in this last octet. This is the mask. And our block size is 8. All right, we are off to the races. So now that we have that block size, what we could do is we could take 1033.73.0 and just add 8 and add 8 and add 8 and add 8 and add 8. And if we had like this, just like a mile of room, we could list all those possible subnets. Because 1, 2, 3, 4, 5, if we have, well, we don't know where we started with the mask, but we have a lot of possible subnets, and if we wanted to list all of them, it would take a long time. So the shortcut is we are going to take the octet. We're talking about this last octet right here, where that mask is splitting and dividing that IP address in that last octet, the customer's octet, and divide that by the block size. And we'll do that math over here. So the block size is 8. And the customer's last octet here is 213. And so 8 goes into 21 2 times. Because if we tried 8 times 3 is 24, it's too high. So 8 goes into 21 2 times, that's 16. Doing the math that I learned in school. And because I don't have a college education, it was probably somewhere in elementary school that I learned this. Still going strong after all these years. And I would take the remainder, so I would borrow the 1. So if they don't teach math like this to young people, or maths if you're in Europe, this is the way I learned it. So 6 and 6 is 12, that would make it 9. Oh, that'd be 15, sorry. 6 and 6 is 12, that would make it 5. So 16, yeah. And the way you can check that is this number plus this one. If it equals the top number, you're in good shape. So that would be, oh my gosh, my brain. Okay, so 1 minus 1 is 0. So the remainder here is 5. So 8 times 2 is 16. The remainder is 5. We bring down the next character of 3. And then the question is, how many times does 8 go into 53? And it doesn't go in, let's see here. 6 times 8 is 48. I'm going to go for that. I'm going to say 6 times 48. And then the remainder is 5. Is that right? 48, 49, 50, 1, 2, 3. Yeah. So the remainder is 5. if my math is right, and if somebody wants to double check me on that, that's great. And then we'd have a remainder. We do it again. But we don't care about anything after this point. So then the third step is you take the result, which is 26, this result right here, and we multiply that by the block size of 8. So let's do that. 26 times 8. 6 times 8 is 48. 8 times 2 is 16. 17, 18, 19, 20. 208. So that would mean we're going to take this number. The fourth step is to plug it in. Plug in that number in that last octet. So this would be network 10.33.73.208 with a slash 29-bit mask. And the next subnet would be 8 more, because that's our block size. So the next subnet would be 216. That would mean our range here would be .209 through 214, with the broadcast address for network A being 215, and the next subnet being 216. Now I have reason to believe that that's true. I do. And what's one way we could test that? I don't have a router up at the moment, but do you know what I do have? I've got a computer right in front of me. I'm on it. So let me go to network connections, and I will make sure we can all see this. So this is my computer. I'm using private RFC 1918 addresses here in the studio, so won't be too much of a problem. Change adapter options. Here's this interface right here that I'm on. It says KBG Wi-Fi, but it's actually a wired connection. It's Ethernet. And let me I don't want to blow out. Oh, yes, let's play with this one right here. Properties. Yeah. So in VMware Workstation, it's got control of this interface, but we can use it here as well. Let me minimize a couple of these. Oh, hold on a second. I need the information back here. So if this is the 208 network, I'm going to jot that down on a separate piece of paper. So 10.33.73.208, and the valid host range is .209 through 214, and the mask is a /29. Great, which would be 248 in dotted decimal for that last octet. That'd be 128 plus 64 plus 32 plus 16, which is 240, plus 8 more would be 248. I just want to be able to put that IP address on an interface on this computer, and then we can actually look at the routing table, and it will tell us whether or not what the network is. So let me go back here, and I've got a window for that. There we go. So I'm going to use a specific IP address, and let's go ahead and pick 10.33.73.20. Let's use the range is, let's use 212, or let's use 213. That's in that range. 213, and here's the mask. And the reason this is relevant, because IP subnetting works on all the devices, whether it's Linux, Windows, routers, multi-layer switches with VLAN interface VLAN interfaces. And we'll go ahead and put the mask of 255.248, which is those additional bits in that last octet. Yeah, that sounds right. And we'll click on OK and OK. And now to see the results of that, let's do this. We'll bring up a command prompt. This is PowerShell, but it'll work. And let's do a route print. So route print from a Windows machine is showing the routing table on this computer. And now I need to find the 10.33. There it is. See that right there? This says this computer believes that it is on the 10.33. I don't know if is that readable. Is it too small? 10.33.73.208 network. There's our mask. And the interface IP address is the .213. So when we put that interface IP address on, from an IP address on that subnet, from a routing perspective, this computer says, hey, I'm directly connected to 10.33.73.208. And it would be the same thing on a router, Cisco router, or a multi-layer switch. If you said IP address is .213 with that mask, and then you just show IP route, it would say, hey, I'm directly connected to the 10.33.73.208 network. So thanks for that. And then when I go back to my VMware workstation environment, it's going to totally bark at me because the networks are managed there through the VMware workstation utility, which is what I'm using for a virtual environment to support my viral. Okay, so I think that was all due to, coming back here, that was all due to Dan's request. Dan, thank you for that. A great way to finish off. And so in the back of my mind, I'm thinking, is all my math right? I think it is. I think it is, and we verified that. We verified it's the 208 subnet on paper, and then we applied an IP address from that range on a computer, and then we did a route print on that Windows machine, and it showed thought it was connected directly to that 208 subnet. So thanks for the opportunity to do that one more. I would encourage you, yeah, great feedback, people, fantastic. I would encourage you to practice that, and make sure you're comfortable with that. And we're going to continue our discussion with Subnet Saturdays with, let's see, the next one I think we're due for summarization. That's what I'm thinking right now. So summarization of taking many routes, and instead of subnetting, making the mask longer, we can do summarization, also called supernetting, to have one route represent a whole family or whole group of networks, which can make our routing table smaller. I mean, why bother memorizing that there's 42 routes out this interface if I can summarize those with 1 or 2 routes that cover that entire address range? So all that's coming up. And GoTrek65 is asking for a link for the server, the Discord server, and I happen to have that right here. Let me bring it up. Thanks for the request. I can copy and paste with the best of them. And paste. Okay, Dan's asking about that last scenario, which is a great question. And I'm going to just go ahead and read that question, make sure I got it. Let's see. Dan's asking, or saying, thank you, I understand, but now where from the 214? So from this point, we have the subnet of 208. The range is 209 through 214. The next subnet is 216, and that is the next subnet. So if we want to know the range for the 216 subnet, we'd add the blocks. If we're doing the same mask every time, so we're not doing variable length masking, we put on that next block size. The next 216 plus 8 more would be 224, I believe. Yep, I'm just doing the math in my head. And then that means the range for that next subnet would be 217 through 222. Next subnet is 224, and we just continue that. If you're using the same mask, add the block size. That's your next subnet. That's the range. And Bob's your uncle, as they say somewhere. I'm not sure where. Bob's my dad, not my uncle. All right. Let me see if there's any final last questions in the queue. And do I know the Muffin Man by chance? Mash, I do not. I would like to. If he's willing, have him join the Discord server so I can get to know him. All right, that's it. See you tomorrow if you can join us for the CCNA Sunday. We're taking a look at NAT. I've heard many people discuss NAT, and sometimes this is a little negative, which I don't like going down that road very often. But sometimes as trainers over the years, we get a topic. It's like, oh, I just have to survive that part in a live class. I have to survive that part, and then we'll go on to something better. And sometimes trainers don't do what's in the absolute best interest of the learner, which is this. I'm just telling you, if a trainer is teaching a concept, it is in the best interest of everybody involved to study that concept, make sure they understand it, find an analogy or a metaphor that is correct. That way we can take something that we know. Like a VLAN is like a room full of people. You shout, everybody hears it in that same room. That's what a VLAN is. A layer 2 broadcast domain. So take an analogy like that and then apply it accurately, which is also important. And that way when people walk away, they can know, oh, I get it. I get how this works. I get the NAT commands for the NAT options for inside local, inside global, outside local, outside global. I have heard that 5 different ways to Sunday, or maybe 6 different ways to Sunday. And many of them are wrong. They're a wrong way of looking at it. It's like, What, you read that out of a book from somebody who wrote that, and then you're repeating it, and you run. So that's our topic tomorrow. It's been a pet peeve of mine for a long time with NAT, Network Address Translation, and how it appears in the output. Most people gloss over it, or they talk about it incorrectly many times. And as a CCIE for route switch first and then for security, I had to dive into NAT with ASAs and firewalls to really understand it, not just from a security perspective, but to make it really work. And that was a long time ago. Now, since then, I've revisited that topic, and I've had opportunities at major companies when we got bought out, like when Paramount Pictures was bought out by Viacom. We're talking about a huge company being bought out by a much larger company back in like 94, 95. We had overlapping IP addresses. I mean, we had 10s that matched their 10s. And to make that all work until we could readdress, we had to do bidirectional NAT, which is lying to each other about the addresses. And so I've had, long story short, I've had an opportunity to practice and work with that in the production environment. And tomorrow, I'm just going to lay it on the line as far as, okay, here's a great way to look at this. Here's how it works. Give you a couple concrete examples. And if you join me for the IT ELF discussion, where IT ELF can help remind us the process to going into full adjacencies of the OSPF, the init, the two-way, the xstart, exchange, and loading, and going into full, IT ELF, IT ELF, IT ELF. It's hard to forget that. And what I'd like to do is give you a way that when you see a show IPNet translations in the future at a command line interface, or if it's from an output, maybe you had an automation device, gather all that data, print them off on 5 different routers regarding their translation tables. When it says inside global or outside local, I want to give you a very quick way that you can say, oh, I totally get what that is, and I totally get the perspective, and that's going to make it much easier to troubleshoot and implement the commands in the future. So thank you very much, everybody, for joining me. I'll see you tomorrow, same bat time, same bat channel, 11 a.m. Pacific for CCNA Sunday as we discuss the world of network address translation and the terminology from the show IPNet translations. And with that, I leave you with a song and a wish in my heart for you, my friend, to succeed big time. Bye, everybody.